This meeting is being recorded.
All right. Hello to everyone and welcome to today's session. My name is Carlo Bobilas and I'll be your moderator. Today's session will be presented by Technical Marketing Engineer Leader Eric Rennie. But before I hand over the mic, I do have a few housekeeping items to cover today's session. Today's session will be recorded and made available on demand. We'll make sure to provide some details at the end. Also, we'd love to hear from you during today's presentation. If you are on WebEx and have a question for our speaker, please feel free to send it through the WebEx question and answer panel, where our wonderful panelists are ready to respond. For those tuning into our live stream, we thank you very much for joining in as well. Q&A is limited to those via WebEx. However, we will have a post-event Q&A thread over on the Cisco Learning Network community where you can post any follow-up questions. So without any further ado, I'd like to kick things off by welcoming Eric. Eric, over to you.
Thank you, Carlo. As Carlo mentioned, my name's Eric Rennie. I'm a TME, a long-winded job title there, but you'll see why in a minute. In this session, well, I'll just say good morning, good afternoon, actually. In this session, we're going to cover bringing network detections and visibility to Splunk. And like Carlo said, if there's any questions, please answer them or ask them in the Q&A panel, as I won't be able to see them live. In today's agenda, in this session, I want to cover why is Secure Network Analytics Splunk, what is the use case? Why is it better together? So we're going to go a couple of slides on that. I'm going to give a very brief overview of what Secure Network Analytics is and what Splunk is. So this is not a deep dive into those particular solutions, just a very light overview so you can understand this session. Then I want to talk about what is the pain points? Why network analytics and Splunk are better together? What's the pain point? What do we resolve? How do we help each other, basically? And then in basically sections 4, 5, and 6, I talk about in a bit more detail how we get data into Splunk from Secure Network Analytics, how we're able to view that data, what mechanisms we can do, and what we can do with that data. So once we've got it in, fine, great. What's the value? What additional value can I add? And then obviously at the end here, we'll wrap up, and obviously there will be some times for some live Q&A if possible. So let's get straight to it. So what is the use case for Secure Network Analytics and Splunk? And what I've done here, I've created a little analogy. It's probably a bit more George Well 1984 kind of synopsis here, but anyone can remember that. But what I do like about this kind of analogy I've done here or story is if you imagine today in some locations, if you have like a bustling city and you have a lot of CCTV cameras covering every street, every alley, monitoring those snippets of activity or what's happening on those streets and alleys. Imagine that basically Secure Network Analytics is those cameras. It's using the cameras, or we like to say the network, those network appliances, as the sensors. So we're observing the flow of data, observing the flow of people, if you want to look at it that way, across the data network, rather opposed to alleys and streets. But think about this. If we're the sensor and we're capturing all that information, that could be overwhelming. If you think about it, if we send all that information to, say, for example, the city central location, or should we say CTV station, in this particular case, which would be our Splunk. Think about the amount of raw footage that would be sending into that one location. But the beauty of Secure Network Analytics, what we're adding here is that we can cleverly compress, stitch those snippets of information, I imagine us taking that video, into coherent stories. So we reduce the data volume. We make more sense of what is being sent in for the analysts to basically monitor and look at. So we're trying to ensure that we're only sending the most significant highlighted events into that security team in the SOC or SNOC, if that makes sense. So if you imagine today, a lot of, as you probably, some of you may have Ring cameras, for example, they're motion sensitive detected. Think about that as Secure Networks doing the same, doing that, but basically on the network activity. Obviously, we're constantly monitoring and recording, but we're adding some additional ability to compress, stitch, reduce that volume, and make sense and run analytics on that before we send it off into the security operations center to be processed. So just kind of setting the scene of what the use case is here. And the core message of the session really is let's bring network visibility into that SOC and SNOC. Now, You might think that's unusual. Isn't that already being done? Well, what we find most of our customers are not actually bringing in that network metadata because it's so much of it in volume. And plus, you have to make sense of it. And you'll see in a couple of slides why that's such a challenge and what we address in that. So this is just to reiterate what the core message here is. Bring that network visibility into my SOC center, okay? So I said we're going to quick brief overview of what Skinner Analytics is. Like I said, very brief, and the same with Splunk. So just to recap for some of you that don't know Skinner Analytics at all, we are basically what we call a contextual network-wide visibility solution. So what that means is we're using, like I said in the analogy there, we're using the network as a sensor. We're collecting what we call flow data from the routers, switches, firewalls, anything that is able to generate what we call the network metadata or telemetry. Hence, the reason why we say agentless, we don't put agents everywhere. We're collecting that information of that. We can also collect it from cloud infrastructure, as we will see in the next slide. So the concept is we're capturing all that snippet of information from all those cameras, from those alleys, from the streets, and we're going to process that information. We're also going to run what we call predictive threat analytics on that information that we've collected and we've stitched and we deduplicated. We're going to run what we call behavioral modeling. That's one of the engines we use, where we look at certain behaviors of devices in the network. Are they acting the same way as we expect them to be, that we've learned the pattern? Also, one of the engines we're going to look at, for example, is what we call machine learning. So we're going to learn, for example, if that particular device is a printer, has it always been a printer? Does it talk like all the other printers? Does it communicate or send the same amount of data, for example? So we learn what that entity is on that network. And obviously, we combine that with our global threat intelligence from our Talos threat research. Obviously, we're looking for bad actors and things within that. So we're processing all that information, we're collecting that network information in, we're making, compressing it, making more sense of it. We're running our various detection engines on it. And then we're going to generate those detections, those responses. And that's what we talk about on the far right here about the high fidelity alerts. So we're prioritizing what is important and what isn't. Well, I wouldn't say what is not important, but the point is it's about low noise, high fidelity alerts is what the end result of security analytics is and the concept from looking at that network information. And in this slide, we build out a bit more explaining what it's doing here. So security analytics sitting in the middle here of this particular slide. We traditionally or always have done collecting information from what we call on-prem networks. So from, like I said, the networks, the firewalls, the routers, the switches, anything that can generate NetFlow, IPFix, SFlow, JFlow. It doesn't matter who the vendor is. Most vendors out there will supply some version of what I call the flow data. We're collecting that information from the on-prem network, the traditional data centers, if you think about it. We're also collecting from endpoints you see in the middle of this slide. So there's something in the Cisco security client called the Network Visibility Module or MVM module. When that's enabled on that remote workstation, for example, a laptop or a PC, we get additional flow information or NVIS flow information from that endpoint. So we're actually marrying up the network information that we would normally get with the process information on that endpoint. So we get to see process IDs and processes executed. We're sending that all into security analytics. On the left side of the slide, you see firewall. We can collect from Cisco firewalls, so our ASAs, FTDs, FMCs, for example. We're collecting those firewall logs. So they've been sent into the same collector as syslog. We're storing them for long-term storage, but we're also running detections on those connection logs that we see. And finally, at the top, you see AWS Cloud and Azure Cloud, for example. We can pull down what we call the VPC flow logs from AWS or the NSG and soon to be VNet flow logs from Azure using something called Cisco telemetry broker. That basically converts those flow log formats into IPFix, which is what Skinner Analytics can understand. So what that means is we get visibility of any cloud workloads, on-prem workloads, the remote workers or remote endpoints, and from our firewall locations. So that's what we're processing. Think about that is not the cameras, but where the sensors are or what sensors we can get information from. At a very high level, like I said, Skinner Analytics has several detection engines or detections that it's running. The statistical anomaly detections, that's the one about the behavior. So, for example, if I started down lots of data to Carlo on the call here, do I normally do that this time of day? Is it normally that amount of data? For example, that's an anomaly in a sense because no, I don't normally do that. We've got policy-based detections. We can set certain policies and look for policy violations. Do I see this particular group of devices talking to this other particular groups? For example, contractors talking to my sensitive financial service, for example. We also do that entity modeling where I mentioned about the printer. We look at a device when it first comes online and we look using our machine learning, what is that device? Is it a printer? Does it sound like a printer? Does it act like all the printers, for example? So we're going to model those entities, which is kind of a key point. Obviously, we've got flow-based detections. That's detection based on that NetFlow or IPFix or JFlow, for example. Also, the engines, as you see, we have MITRE attack framework mapping. So the techniques and tactics, we do that as well. And just recently, we've added Zeek or Brologs, you might have heard of the older name, NBM, and additional firewall detections based on that. So there's a lot of detection engines. So what I'm trying to show you here is that when information comes in from the network as the sensor, those cameras, for example, we're obviously pre-processing, but we're also running a lot of detection engines on there to add value or additional context to what that information is. That was just a brief overview of SNA. Now, Splunk Enterprise itself. Now, most of you probably use Splunk or hopefully are aware of Splunk. And as you know, it's very powerful at data aggregation, searching, reporting, analyzing on anything you send to it. So you send stuff to it, as we'll see, via syslog, webhooks, or anything like that. It's a very good data mining solution. It's great aggregating, analyzing, and basically doing any kind of search on that machine data that you send to it. What I like to say at the bottom here, you can index any data from any source. An index is the key word here in Splunk, as we'll see. The ability to index any kind of data, whether it comes from Skinner Analytics, whether it comes from an endpoint solution, whether it's just a syslog from a firewall, for example, is the key or key to the success, I'd say, of Splunk Enterprise. Basically, the key word is get data in. That's what we kind of like to say on the Splunk side of the house. At a very high level, this is obviously a 40,000-foot view of how Splunk works. There's a lot more to it than this. But the core concepts that we need to understand here is an index. Basically, an index, the way I look at it, is a flat file system that when all that data comes into Splunk, it can index that data or store it effectively like in a flat file kind of system. And you can organize and manage those as you wish. So there's no database schemas or things like that where it has to correlate that data or put that data into specific columns and fields and things like that. That's kind of one of the powers I like about the indexing system. There's also a concept of events, which is usually, like we say here, single record. There's also a metric, which would be like CPU utilization. So some key terms you may come across when you deal with Splunk. Index one is the key one that I'll talk about a little bit more later. Hierarchically, or looking at the architecture at a very simple level, you have what we call Splunk forwarders. These are the ones sending that information into the indexer to be indexed, put into that file system, if you want to look at that. Obviously, on the far right here, I show Cisco Analytics. What we're sending, as we'll see, is the alarms and alerts into the indexer to be indexed, not the raw footage, not the raw footage from the cameras or the flow data that I mentioned. We're not doing that. We're only sending those alarms and alerts that have been generated by those various detection engines that I mentioned. So those are going to go into the Splunk index and be indexed and filed to be referenced. The Splunk search head is where most of us have ever used Splunk are actually reside. That's usually the web user GUI front end there, where you do a search, like I say, search for anything that says SNA, for example, as a source, and it pull up those alarms and alerts. So it's going to search through that. Obviously, the architecture here can get a bit more complicated depending on your organization. You can have more than one index there. You can have heavy forwarders. You can have more search heads. You can do HA, all that great design. But the principle is this. You've got a search head, an indexer, and a forwarder. And that's the main key concepts here. I want to bring up what are Splunk apps because we're going to talk about a Splunk app called the Cisco Security Cloud app. Now, I know that doesn't kind of make sense because it just says Cisco Security Cloud. It doesn't mention Secure Network Analytics. It doesn't mention Splunk at all in the name itself. But it's an app that you can download for free off Splunk base. So if you're a Splunk user and you have a login, you can search for this app. You can install it on top of your Splunk Enterprise. Now, what this app is going to do, it's going to allow us to enable one of the modules in it. So it's a shell app or shell wrapper. And one of the modules is Secure Analytics. It has lots of other modules inside that app, for example, for Cisco's XDR, for Cisco's Duo, and other solutions. So you can see why it doesn't have SNA in the name itself specifically, but it's there to be used for not just SNA, and we'll see why in a moment. So like I said, these apps, they are designed for a variety of use cases, as we'll see. And obviously there's thousands of these ready-made apps. Some are like this one, kind of what we call freshly made. Some are done by partners, some are done by individuals. So there's different kind of quality on those particular apps to look out for. We mentioned Splunk Enterprise, but one of the other apps is Splunk Enterprise Security, which you can bolt on or add on to Enterprise. So once you have that data in, what do we want to do with it? So Splunk Enterprise, if you're running a security operations center, you're probably going to be running Splunk Enterprise Security on top of your standard core enterprise solution. Why would you want to do that? Well, it allows you to build or create bespoke detections built on what we call the SPL or search processing language. That's one of the key concepts in Splunk, and one of the powerful things is that you can create a search string effectively to pull or mine any of the data that's being pulled in. Remember, in Splunk Enterprise, it's all about getting that data into those various indexes. The next thing is then using SPL to mine that data out and make use of it. Obviously, this allows Splunk Enterprise Security to go at a massive scale. It's very comprehensive, and it's able to detect and respond to the attacks. So what we'll see in a couple of slides, and I'll show you how we use Enterprise Security or Splunk Enterprise Security to basically generate what we call notables or findings based on the information that we're sending in. So we mentioned about SNA processing the raw network information, then generating alarms based on its detection engines. And then what we'll talk about is sending those alarms into Splunk, into an index, for example. Well, what the next step is then using Splunk Enterprise Security to basically start investigations on those alarms and see if we can correlate the alarms from Secure Network Analytics with any other a source or index that's coming into Splunk. And that's where Enterprise Security can add an additional layer of what you call enrichment investigation to any security operations center. And if you look very closely on this one on the right, you can see this particular notable finding in Enterprise Security is actually coming from Secure Network Analytics. So we're actually making use of the data that we send in. So let's look at why Secure Analytics and Splunk are better together. Well, what I like to say is, what is the pain point? What are we trying to solve here? Remember I said about the use case? Well, a lot of our customers, the pain point is they basically have a lack of complete visibility into what's happening on the network. There's network connections, both internal and external. And there's lots of historical reasons for that. Some customers will take the network telemetry directly into their Splunk, for example, but there's some downsides to doing that. Obviously, they have difficulty in baselining that network behavior. They basically have a blind spot to what's happening on the network, what the NDR solutions are doing, the network detection response solutions are doing. Also, it's time consuming and obviously manual to get anything from that network. So most people avoid the network. They just take information in from certain choke points in the network, maybe from the firewalls, maybe from certain other devices to monitor what's happening. The actual desired outcomes of most customers and most users, as we see in the middle here, is they want to visualize those connections, those flows. Remember the video analogy at the beginning of the presentation here. They want to know what the network is doing. Use your network that's already there. use those appliances as the sensors, as the cameras. Also, we don't want just to pull in raw information. We want to use machine learning based alerts to be triggered on deviations. We want that additional processing before we see it. We want the ability to automatically respond to any actions that we see or policy controls that are being violated. The end point here, or the result we're trying to achieve in the green here on the right, is we want cost-effective storage of those events within Splunk by reducing the amount of raw footage that comes in. We also want to make the integration seamless. We want to see alerts correlation within other events within the SIM. So we want to see the network alerts alarms that we send in from the network from Skinner Analytics also correlated with other events controls that the SIM that is seeing from other sources or other indexes. And we want to make it highly customizable. We want to be able to automate those responses, whether it's from the SIM or from Skinner Analytics itself. So the challenge to do this or bringing those network detections to Splunk is highlighted here. So the challenge today, if we're getting that metadata or the flow data from the network, it's actually high volume. It's not payload data we're getting. We're getting kind of header information of every conversation or flow that's happening across the network. One conversation or flow could actually go across 5 or 6 hops typically. If you think about it, if I'm talking from my laptop and I'm talking to a web server that we're on at the moment, for example, I'm going to go through multiple hosts, through routers, through firewalls, switches, and things like that. So potentially I could get 5 to 6 copies of the same flow record just to make up that one conversation. And obviously the conversation is not bi-directional by default. If you look at the network routing, I could be going via one direction to get there and a different direction on the way back. And obviously, we're exporting this information from those network devices, those sensors, those cameras every 60 seconds. So you start to see the challenge. Even though we're not capturing payload information, the volume of the flow data could be potentially quite large. So this is where SNA really helps. We act as what I call a deduplicator between the exporters and the SIM. The exporters being those network devices. So we're going to stitch that information together. So that bidirectional flow becomes a unidirectional flow. Think of it, a flow is like a phone record. When you look at your phone records, you don't see every cell tower, for example, that a phone call went through. You just see who called, well, I should say the source of the call, the destination, who you called, the calling ID, the length of the time, and the numbers, for example. That's what we're doing here. Effectively doing that for the network data. So we're reducing the amount of flow. So if you look at the little diagram, we have the network. So the firewalls, the routers, the switches we see. There are sensors, there's our cameras monitoring all that activity. The flow collector appliance you see here is doing the heavy lifting for us, or the heavy work. It's doing the data duplication, it's stitching the flow together, it's running some of those algorithms or detections engines on for us, and then depositing those results in the data store, where we can save that information long-term wise on-prem, for example. Then what we do is we configure what we call the management console, the SNA management console, to send specific alarms or alerts into Splunk for the SOC team to act upon. So you can see where we're reducing the amount of information and information overload to our SOC teams. So as we're going to cover in the next section is how do we get data into Splunk? And there's a couple of methods that I've listed on this slide in the middle here. The most common method to get detection anomalies into Splunk is using obviously syslog. Syslog's been around for a long, long time. There's nothing, what should I say, rocket science about that. Obviously, webhooks is a bit newer. So there's several ways we can get that raw information into Splunk. We use something we call in Skinner Analytics called response management. And we'll see a quick demo of that, how that gets data into Splunk using either syslog or webhooks. The other method we already just mentioned is using an application that we call Cisco Security Cloud App. Remember, that's a Splunk-based app that we can deploy on the Splunk enterprise itself, the basic Splunk core. And that uses an API. It's using an API to populate dashboards within Splunk allows you to pivot from Splunk into SNA on Alarm if you wanted to do that. And for enterprise security or EAS here, it allows you the ability to create what we call notables or findings in enterprise security. It will do that for a specific set of alarms that we generate. So you don't have to go and mine out and create the rules in enterprise security. It will do that automatically for us. So it maps, as we'll see, information from the alarms we generate using the Common Information Model, CIM, which is an expression in Splunk, into the format that enterprise security can understand, and then display that information. So now we're going to break down into kind of three sections here. How do we get that data into Splunk? We kind of mentioned it already at a very high level. We're obviously going to use syslog and webhooks, but the point here is, what are we going to do? We're going to get those network detection response outcomes, i.e. skin analytics in Splunk, using that webhook or syslog. My preference today really is using webhooks, to be honest. And the reason for that is you'll see it's easier to configure. It provides a lot more information than traditional syslog messages can do. So if I'm setting that up, I would prefer to use webhooks these days, but you can still use syslog if there's a limitation there. Obviously, the detections that we're setting in Splunk are going to be indexed. I already mentioned that, but they're going to be put into specific indexes that once that data is in, we can search that using enterprise security or just a general search from the search head. We're also going to pivot from Skinner analytics, so we can actually pivot what we do call external lookup from a specific host or IP address. We can say, go show me what you know about this particular host in Splunk. It will then search Splunk indexes for any IP address or any related information based on that host, as an example. And obviously, we can configure any alarms and alert rules within SNA, so we can control the volume or what type of alarm alerts that we need to send into Splunk. So it's quite a lot of control we can do with SNA. And I'm just going to build that out on a couple of steps here on this slide. So we mentioned Response Manager. That's the main, should we say, module within Skinner Analytics that does all this responding for us, or sending the information. It's going to send those alarms and alerts into Splunk. My preference, like I said, is using webhooks in this example. The bottom screen here just shows what the information, I know it's very hard to read, but it shows what a raw search of that index would look like. And there's a lot of detail you can and cannot probably see on the slide, but just trust me, it's there. But once we have that raw information in, we can do some very basic manipulation you see on the right here. We can create some basic dashboards of alarms and alerts. The two dashboards on the right are actually different. They're looking at different detections. Remember, I said there's multiple detection engines. The one's looking at the behavioral alarms, and the one's looking at the entity modeling alerts or entity-based alerts. Obviously, once we've got that information there inside an index, we can use enterprise security or Splunk enterprise security to mine that information and add it and look for other correlations, or use it to create more, start what we call an investigation, and do further investigation with anything we see from SNA, the network, from other sources of information. Now, we do have a short demo here I can show. It's about 6 minutes long, so I'm just conscious of time. I'll try and play it through so you can get an idea of how we would configure this. I may cut it short just in case, to make sure we get enough time for the rest of the session, but just bear with me. But in this demo, what you're going to see is what methods we use to send alarms and alerts into Splunk. You're going to see how we can query that, how we can look at the indexes so we can prove the data's there, how we can create some simple dashboards just based off that raw information. Well, not raw information, but those alarms and alerts that are just sitting in a basic index in Splunk. And how you can pivot from Skin Analytics into Splunk into that information. Remember I mentioned external lookups. Okay, so just bear with me, there's no audio with this, but I'll walk you through it. So in this quick demo, what I'm showing is where I click on configure. This is where I'm going to set up the response manager. Remember, this is the part of SNA that creates or allows us to configure the syslog or webhook responses. And you'll see what that means. So if I'm doing syslog, I have to configure the syslog format. So here I'm just showing a very basic message format. You can manipulate this. You can add additional alert variables. There's an option at the bottom here. You can even preview what this would potentially look like or what we're sending into Splunk. You can see I got two different formats here. One for the alarms, and actually one's what I call CA, or Converged Analytics Alerts. Remember the alerts, the ones based on entity modeling, and the alarms are the behavioral modeling detection. So they're different type of alarms and alerts. Like I said, the CA alarms will send MITRE, for example, framework tactics and techniques information, while the traditional alarms does not. The next thing we do from response is we configure an action. So we got the syslog format. Now we got to tell it what to do. So this is the action. And you see again, there's two actions, one for those converged analytics alerts and one for the alarms. So under here, the converged analytics, all we're doing is pointing to my Splunk server on syslog port 514, and I'm choosing the converged analytics format. So I'm just matching the action to the correct format. And as you can see, I can do a quick test just to make sure that we can send that information off into Splunk. On the webhook, it's going to be exactly the same, or very similar, I should say, not quite exactly the same. But here, we're just checking out again the information. Here it's slightly different. Notice the webhook, we have to put the HTTPS URL. So that's connecting into the WebSocket on my Splunk server. We do have to put in some security details like the username and authentication password for that WebSocket to actually work. So that's one of the major differences. One's using obviously syslog, one's using that webhook. And then on the final configuration, this is where we define what alarms, what priority, what level do we want to send. This is how we control the volume of alarms on alert. Here, obviously in my lab environment, I'm saying the priority is low, so anything that's low or higher. Obviously in the real world, you probably would not do that. But obviously in my environment, I want to do that to make it look more interesting. And notice I can get it to send the alarms when the alarm triggers and when it closes. So you can get it twice or once if you wanted to. And notice I can enable it for the Splunk action and for the syslog action. So I can send it in for both. And that's basically how we configure that information. So that's getting the data into Splunk itself. Here I'm just showing again that notice the rule information is different. It's about severity and minor, not priority. Again, the two detection engines, the rules are slightly different. That's why I configured it twice here. And I'm just showing you again, the actions are the same, that we can configure those to send it on both particular cases. Yeah. And then what we will show then is we'll jump into Splunk, and this is what it actually looks like. Here I did a very basic search in Splunk. I just typed in Cisco. Obviously, in a more busier Splunk environment, you probably want to refine that search, that SPL, that search process language there. But you can see I'm just showing this is a traditional alarm coming in here. You can see some of the fields to show you the wealth of information that's coming into Splunk and what we're looking at the moment. So again, this is just kind of like the raw index information. And you see the different sources here that we set up. So the HTTP event one, that's obviously the WebSocket as a source type. And you got the source at the bottom, obviously what we defined from SNA. You can see here, I'm just refining the search a bit more to focus in on those ones, those particular alarms. Again, the alarm category is address scanning, and that's what you would see within SNA dashboard itself. And I can look at alarm type. Now, I did alert type just to show you the difference here. Notice you got MITRE tactics and techniques and descriptions coming through. Remember that the CA Converged Analytics alerts has that MITRE mapping. So that's why I wanted to show it's different information coming into those indexes. And here, I just wanted to show, once I got the data in, I just created some very simple search strings to create a dashboard. So I'm not doing anything rocket science here. I'm just creating a very search string, looking at the alarm type. And that's what the first dashboard is here. That webhook alarms by type the last 7 days. And unfortunately for me, the big purple spike is the address scanning, which is drowning out on the graphic on the top, all the other interesting alerts. But I've done the same for the dashboard below, but this time I searched by alert type. That's the only real difference between the two dashboards here. But it shows you the two different types of alarms and alerts that we're sending into that index in Splunk. So it's kind of a good visual way to make sure that we're seeing those alarms and alerts that we want to process, as we'll see, using in the next section, the Cisco Security Cloud app and obviously Splunk Enterprise Security. Also mentioned that we can actually go from SNA and pivot into Splunk. So we use something what we call external lookup. I can pick on an offending IP address here, one of the hosts listed. I click external lookup and I say search for that IP within Splunk. So showing you that we can pivot from SNA to Splunk. And what I'll show you later is from Splunk back into SNA. So it's not one way or one direction here. And you can see it's found anything associated alert with that. Now, obviously here, I'm just looking at the raw, I hate to say raw, but I'm just looking at the index information, the temporary stash index information for that particular host. And I can see what particular rules. Obviously, I could then manipulate this information using SPL if I wanted to do something else for that information. So here, just showing you the kind of syslog information that we've provided on that. Yeah. Let me just stop that. So there's a lot there. So we got data in. I showed you getting data in and how we can pivot from SNA in. I showed you how we can see that data, what it looks like in an index. Remember the flat file kind of structure in Splunk, where I showed you how you can do some very basic dashboards based off that raw information. Now we're going to switch slightly different. We're going to talk about that Cisco Security Cloud app. Remember, this app is not using syslog or webhooks to get data in. It's using API to pull information out of the Secure Analytics Manager. Now, this is, like I said, the free app. We don't have to configure anything on this. Well, we do have to configure. We have to tell it where the SNA manager is, its IP address, and a few other credentials. But after that, it will use an API. The beauty of this is it's high efficacy, low noise. It's going to pull those particular events and display them. It's going to take some of those alarms, just the alarms on the alerts in the index. It's going to map them, like I said, to that common information model. So it's basically convert them into Splunk terminology or attributes, I should say, that it can understand. And it's going to do that because it allows us to promote those events into enterprise security, into what we call notables or findings for further investigation. And this is me just building it out again. So you go to Splunk base, you download that app, you install the app on your Splunk Enterprise or your core Splunk. You configure it, and once you do that, you'll see you get 3 dashboards that's going to populate by pulling information from the API. First one's going to be the Network Insights dashboard. That just gives you general overview of what the network's doing, how much data's come in and out particular groups, where it's going, and things like that. It also has a second one called the Security Insights dashboard, which is going to show you the alarms and alerts. So it's pulling out what is critical, what is major, and what is minor. Again, you can configure those thresholds of what you want to display within the app, within on Splunk Enterprise itself. Also has alarm details at the bottom there. You'll see you're able to look at what alarms are generating. For example, we can see suspect long flow, for example. And on the actions column, there's ability there for me to click on the action columns and pivot back into Skinner Analytics to see who that offending host is and why they're generating that alarm. And then I can drill down into the flows and a lot more detail on that information. And finally, you'll see this ingestions tab. So you've got basically 3 dashboards you can look at. You can look at the network side, what's happening on the network, volumes of flows per second that we see. You can see then the security dashboard, see what alarms and alerts are being summarized or being pulled up from that. And then finally, we can look at, for example, how many flows per second, the volume of data that we're processing daily. And you can see some of those numbers on the screenshot, 15.5 terabytes, for example. That's a lot of information we're processing. Remember, we're not sending that into Splunk. That's just what SNA is dealing with at that moment. So the beauty of this app It allows the SOC analysts not to leave the comfort of Splunk. They can view information from the NDR, Skinner Analytics, from within a comfortable environment, and then get a summary of what's happening on the network. If they want to, they can drill down in through the alarm details dashboard there to get more information directly from SNA. And then, like I said, go all the way down to the flow level or flow conversation for that particular alarm or alert. And this demo is just going to show you briefly what I just said there. It's going to show you the app there. This app is what they call a technical add-on, a TA. So what I showed you in the first demo was us getting data in. That is not a technical add-on. It just gets data into an index and leaves it there. It's up to you what you do with the data. Now, this app being a technical add-on is different because it's actually inserting alarms into the Splunk indexes and it's converting them using the CIM format and producing findings in enterprise security. So it's doing more than just putting data in. So I wanted to highlight that by the technical add-on. Okay. So if we quickly play this one isn't as long as the previous one. So you just bear with me. So you'll see me jump to Cisco Security Cloud app. It's already installed, and I just show you how it shows up. Like I said, most people get confused because it does not say secure now, and it's in the app's name. But this is one of the modules, and we're just looking at the alarm severity. Again, you can control this when you set up this app. What alarms? If you just want to see critical and not major, for example, you can do that. We get a quick short list of obviously devices with the top findings. We get severity. We get a look at findings by alarm type. So we can look here, there's some peer-to-peer to internet traffic that we're seeing, some anomaly detections, there's some command and control, there's address scanning. So this information is all information that's been displayed within the SNA Manager user interface itself. In the alarm details panel, we get a bit more information about the current alarms we're seeing there. And remember the actions column there, we could click on that and pivot back into SNA if we wanted to. We mentioned the Network Insights dashboard. This is obviously showing me the last 24 hours on the filter here. It takes a little while to pull that information via the API, but you see in the last 24 hours that we've seen 1.4 terabytes in total of traffic. 1.1 of that's internal, so that's going within the network, not coming from inside to outside. We show what inside is basically anything internal. Anything that's outside is basically in a customer environment going to the internet. So from customer, say on-prem, going into the internet. So you can see the volume of data and the locations it's going to. We get to see who the top host is, top talker effectively, what's the top port, what port is being used the most. And again, we get the top conversations. Remember, conversation is that flow. So we see who's talking to on what port and how much data they've transferred. And then on the third panel is the ingestion. So here it's giving us the maximum flows per second. Now, Secure Analytics is licensed and actually engineered based on how many flows or conversations it's processing per second. So you can have a quick snapshot of how many conversations it's processing there, the amount of traffic, the flow rate, and a collection trend by collector. You can have more than one flow collector. Remember on the one slide I showed the flow collector, which is bringing all the information in. It's doing the stitching, deduplication, and all the great cool stuff. So here we only have one in this environment, but you can have multiple collectors doing that across the networks in your environment. Okay. So I'm waiting for myself to catch up here. I'm just going to show the pivoting. So if I click on the pivot there, and we'll show there that here, that's the same event. We can see that suspect long flow. So now we're in the Secure Analytics dashboard itself. And that's what's said by drilling down to the flow. I could then click on the actions column and say, show me the associated flow with that suspect long flow alarm that we saw. And you can see what SNA is doing now. It's doing a search query into that data source. Remember that one architecture diagram or SNA, we had the data store, and it's pulling out the flow logs here for me. And it's providing a certain amount of detail of that individual conversation that generated that suspect long conversation going on between this particular host inside my network to what looks like it's a Yahoo address. So that might be worth investigating, or maybe it's expected, but it's just showing you that as visibility. And last thing on there, enterprise security. Now, if we look at enterprise security, remember that is a technical add-on app as well for the security team. That's going to show us here the security posture based on the information coming in, and you'll see some of the alarms here. Suspect long flow is there. That's coming from SNA. And we can also look at what we call mission control alerts. And this is where we start to look at, for example, address scanning. So that's the one coming to traditional alarm. And we can actually start doing investigation here. There's a top start investigation button at the top, or we can just simply add additional context to that, depending on what we want to do in enterprise security, which is highly flexible. So this is where your security analyst would sit. It would use that network information about the address scanning, and they could then do various things like add to investigation, assign himself, and various things like that. So we're just showing the flexibility here of potentially changing that or adding different events or classifications to anything that you see coming in from the network. So I said the first demo, we got data in. This one's showing how you can view it by the CSE app, and that the CSE app is converting this information like address scanning into notables or findings within enterprise security for the analyst to do further investigation. So finally, what more can we do with that information? Well, what we can do more with that information is within enterprise security. We just had a brief taste of it. We showed looking at the address scanning. But the beauty of enterprise security, it has a lot of what we call detection rules already built for us using the search processing language, the SPL. What that means is we can take advantage of risk-based alerting or RBA within enterprise security. Now, RBA is the concept of we're not going to generate an alarm every time we see a specific behavior. Well, maybe that's the wrong way to put it, but if you look at the graphic at the bottom here, you see at 6:55 a.m., you see a potential spear phishing attack. We're going to weight every potential observation that we see from a host. So in this example here, we're giving it 10 points. At 6:58, we see suspicious command and control. We give it 15 points. Now, we're observing these. We haven't generated an alarm yet, okay, or alert. We see suspicious PowerShell from that same host at 7:03 a.m. We give it 20 points. So you get the idea. We're observing the behavior and giving certain points or risk score to that. Then eventually at 2:15, what we'll see is we give an additional 20 points. That goes above a risk incident rule that we configured that say that if we see any host that goes above 100 points within 24 hours, for example, we're going to generate an alert based off that information that we see coming in, and we're going to put that into something we call the risk index. Once it's in the risk index, we can run additional rules on that and put it into the notable or findings index. So remember, Splunk is all about indexes, storage places. So what we're effectively doing is we're taking the SNA alarms alerts which are being processed, we're correlating them with other alerts that are potentially being seen within Splunk Enterprise Security. And if we see anything that correlates or breaks the risk incident rule within that time frame, we're going to put that into the risk index. By default, Enterprise Security is already running a bunch of rules that's looking at that risk index for additional findings on that. So it's looking at, is it more interesting? Is it a notable? Do I need to go investigate? So if I see a particular host that's in the risk-based alerting index already because it's already triggered my rule, do I see it acting over the 7-day period, for example? Do I see it doing additional things or generating more alarms and alerts than it should do? Then if it does, I want to know. So it's all about controlling what you see, the risk-based alerting. Okay. And this is what I wanted to demo in the final demo for you guys. We should have just about enough time to do this. So in this demo, I walk through basically 3 rules in enterprise security. So remember the first demo, data in. Second demo, using the app to view it and using enterprise security just to see what that looks like. This one's about, okay, I've got that demo in from SNA. What can I do with it? Well, we're going to look at 3 rules. The first rule is going to look at that risk rule. We're going to look at the information coming in from SNA, and we're going to say over that 24-hour period, if the index is above 100, put that into that risk index. So that's the risk-based alerting. So we're applying some, not filtering, but some control, reducing that noise and say, okay, this is of interest to us. Then we can use two default rules that come in enterprise security, rule number 2 and rule number 3. Rule number 2, it looks at what they call risk threshold exceeded for object over 24 hours. So this is doing a correlation search over 24 hours at looking at the risk index. So it's looking at the SNA alerts, and if it exceeds that threshold, it's then going to generate a notable finding, and it's going to place that into the notable index, that's storage. Rule number 3 is going to be looking at that notable index over a 7-day period, and it's looking for any host that has multiple MITRE tactics generated by it from a single device. So that means if a single host within the environment has generated 2 different MITRE tactics, for example, then fire this rule. That rule is going to be less noisy than rule number 2, but it's just a good example of that. So in the demo here, oh, sorry, let me go back one. Play that again. So in the demo here, I'm just going to show you that in enterprise security. So you see me just showing where we went for before. We're going to look at the 2 main places in enterprise security is the mission control and security posture. Security posture gives you an overall view of your whole security posture based on that. But what we'll see here is that when I catch up with it, I'm looking at the rules. So this is that first rule I mentioned, rule number 1. So that's a risk rule. That's going to go through and it's going to pull out information from SNA. So that information that we're already sending into that initial index, that common storage, the rule using the search here, so that's SPL language, is going to pull out those events over that 24-hour period. And there's a lot of stuff you can do here. So this is getting way into the weeds with enterprise security, but you can see how powerful enterprise security is that the analyst can customize this rule. You see I'm adding a risk score of 5 every time I see something. So remember, when we trigger over 100, that's when we want a response. So I'm looking back 90 days, and I'm running this rule every 1 minute. So this could potentially be very noisy in a normal environment. I wouldn't kind of recommend that. And you can see you can cut and paste that into a search, and you can see what the information would look like. So this is what the information looks like in the index based off that rule query they're written. So you can see the alert description, the next steps, the MITRE techniques. Now that information is coming from, remember, SNA. So SNA is populating that alert next steps and all that information. Rule number 2 is looking at that risk index. So I just show the rule here. Again, you can see the detail of the rule. It's using RBA, if you remember, risk-based alerts. So I'm customizing a default rule. That's why it's a lot more complicated rule when you look at it. There's a lot of information to that. But basically, I've only tweaked that rule slightly to basically look at those MITRE tactics and techniques for us. But I'm showing you again here the ability of how you can customize rules within enterprise security. There's a lot you can do here. Again, I'm going to look back this time, the last 30 days, and run this every minute. Again, in real environment, I probably would not run this every minute, but being my lab, there's not a lot of activity in that. So we obviously run it there. Okay. And you see when we visualize what this rule looks like when we do a search, you see it's showing again the technic IDs, the tactic IDs, and some additional information, tagging information in the source of where it's getting from. Now you notice the source is actually rule number 1 that we wrote. Because remember, rule number 1 gets it into the risk index or the RBA kind of system. And this is running and looking at that and then generating it into the notables index. And you see the original source there. It's probably a bit difficult to see there, but you see where it's coming from. Unusual DNS connection. That was the original SNA alarm alert that particular host was generating. And then the final one here is what we call the attack technique threshold. Again, this is a default rule. An important thing is at the bottom of this rule here, you probably can't see, but I'm looking at a condition where the MITRE technic ID count is greater than 2, from one source. So there's 2 bits are modified on this default rule, saying if I see anybody in this environment that generates more than 2 MITRE techniques from one IP address, then trigger this. This one I'm actually running every 5 minutes rather than every minute. And again, if you cut and pasted that search into, or SPL language into search, you'll see what I'm looking at. You see I've got one host here that's actually generating 3 Tetic IDs and 2 techniques. So this will trigger this particular alert, as you'll see. And that's what I'm highlighting there in the query, what I've modified. So again, I'm just taking a default rule, moderate it slightly for my use case here. Now, this is looking at those converged analytics alerts, not the traditional arms, because remember, only these ones have the MITRE mappings on them. So there's a lot there, but I just want to show the power of once you've got the data in from the network, what you can do with it. So just to quickly wrap up before we run out of time. So like I said, there was a lot in this hour here. What we actually covered today was how SA brings those network detections, hopefully that was obvious here, to the network, to the analyst in that SOC center. Explain why, hopefully you understand better why SA and Splunk are better together. You know, they're complementary of each other, they help each other out here. How we can get that network telemetry into Splunk, and how we can view and manipulate that data once it's in Splunk. How we can do those additional investigation, which I just showed you, by creating additional rules to basically mine that information or manipulate that information. So the analysts have the capability now to use the network information to do deeper and more, should we say, exhaustive investigations. Okay. That brings me to the end of my presentation. I said here on the additional resources, there's some additional information here from learning from this particular session, and you can view that at your leisure. Thank you for listening. Hopefully that was helpful to all of you on the call.
Awesome. Thank you very much, Eric. Great presentation. At this time, we'll go ahead and take some questions. So if you have a question, just a reminder, please be sure to type your questions into the question and answer panel. All right. So first question is, are we to understand that while SNA and Splunk have similar capabilities, because Splunk Enterprise gives greater control of data filtering if it doesn't have straightforward DED-UP capabilities that SNA currently inherently has?
Good question, Carlo. I'm not quite sure. Can you just repeat the beginning of that question, Carlo?
Sure. So,
It's quite a long one.
yeah, are we to understand that while SNA and Splunk have similar capabilities,
Yeah.
because Splunk Enterprise gives greater control of data filtering, it doesn't have straightforward DED-UP capabilities that SNA inherently has?
Okay. Yeah. Okay. So that's correct. SNA and Splunk. Well, Splunk Core doesn't have the same capability. Remember, Splunk Core is just receiving that information. It's not doing anything with it. If you add on Enterprise Security app, then yes, that's a security side of the product, which SNA is security. But what Splunk is not doing, it's not deduplicating or stitching the network telemetry, the flow data, as I mentioned. Yeah. Now, Splunk, you can filter, you can create rules to look at the information once it's in, get data in. Remember that analogy. So once you've got the data in, you can do that. What SA is doing is it's stitching, deduplicating. It's not filtering, it's just making more sense of the network information and only sending the alarms and alerts into Splunk, then for Splunk then to mine that data. So it's a different kind of concept. So yes, Splunk is not doing any deduplication, stitching, or any of that with any of that index information that's coming in. Okay, it just goes in there, and then it's up to the add-on app like Enterprise Security to then look at that index of information, and then depending on what rules you set, mine that or manipulate that or display that information. Hopefully that helps.
Awesome. Thank you. I think we have time for one more question. Can you fully recreate the dashboards from scratch? Ultimately, these security apps are just prepackaged automations and features that are native to Splunk. question?
You can, yeah. The first example I showed you, me just creating some very basic dashboards based off the index data, running a query and just displaying them. Now, this Cisco Security Cloud app obviously is different. It's using an API and it's populating this pre-made dashboards, as you said. The difference with that app is that it's not just creating a dashboard. If you don't want the dashboards, that's fine. What it's actually doing is one of the points I was trying to make, and maybe we went over too quickly, was it's taking the alarms, all the hundreds of alarms that SA is generating, and it's converting, I believe by default, the high category ones into notables in enterprise security. So if you have enterprise security, it will automatically generate, for example, you saw on my example, the address scanning, will automatically generate as a notable. Certain alarms won't generate if they're minor, for example. They'll be there, but they won't be a notable. Now, that's what it's doing different, in my opinion, is that it's mapping the SNA alarms using the common information model, basically mapping what we say an alarm is into something that enterprise security understands or into a field. That is different. So if you just want to create a simple dashboard, yes, you don't need to use the CSE app at all. But what I like about the CSE app is that the dashboard's already there for you. You don't have to create some of those dashboards. But also I like that ability for it to map, depending on what I tell it to do, major, critical, high, alarms into enterprise security notables. That is different.
Thank you very much, Eric. And it looks like we've covered all the questions that we have. I want to thank you, our panelists, and the whole team for bringing your knowledge to the Cisco community. Again, if you have a question, I'll keep the Q&A window open for a couple more minutes. I do encourage you, for even more tutorials, demonstrations, and future events, to please visit the Cisco Learning Network, along with the post-event discussion thread. If you do have additional questions or just want to talk with other experts, feel free to jump on. That link is in the chat. On that post-event discussion page, we'll include the link to where the recording can be viewed, along with a copy of today's presentation. Okay, at this time, you'll be directed to a survey, so we do encourage you to take the time to participate. Please let us know how we did, topics you'd like to discuss in future sessions, because your feedback is important. Once again, we thank everyone for joining us today, and we will see you next time. Have a great day.